Good morning all. This is Dr. D. Khalandar Basha, working as Associate Professor in Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we are going to discuss the interfacing of ultrasonic sensor with Arduino to measure the distance between the sensor to the obstacle. So first we will see what is the principle behind the ultrasonic sensor. Here, the ultrasound is a high-pitched sound wave whose frequency exceeds the audible range of human hearing. So the figure shows the spectrum of infrared, audible sound and ultrasonic sound. So the ultrasonic sound will have the frequency which is greater than 20 kHz, whereas we can hear any audio if it is lies between 20 Hz to 20 kHz. So this ultrasound we are going to generate at a frequency which is more than our audible range of frequencies. So the signals which are radiated in this spectrum we are not going to be able to hear. So the humans can hear the sound waves that vibrate in the range of 20 times a second to 20,000 times a second. Nothing but 20 Hz to 20,000 kilohertz. Where this 20 kilohertz we can consider as a high pitched whistle kind of thing. However, the ultrasound has a frequency which is more than 20 kilohertz. So this cannot be audible by humans. Now coming to ultrasonic sensor. An ultrasonic sensor is a device that measures the distance to an object. Let us assume this one is an object. Somewhere here we have the ultrasonic sensor. It will try to measure what is the distance from the sensor to the obstacle. Here it is going to send the sound waves. When these sound waves are propagating, if any obstacle is found, then these will be reflected back. So for producing the sound waves, internally it will have a transmitter. For reception of these reflected sound waves by the obstacle will be collected from the receiver. If no obstacle is present, the sound waves will be propagated, and as there is no reflective medium, the receiver will not receive any kind of signal indicating absence of the obstacle. So the module of ultrasonic sensor mainly uses the two transducer. One is for transmission for high pitched sound, and the second one is a receiver which is going to receive the sound signal bouncing back from the object. So these sensors are cheap, easy to use and do not need much power to operate. So they can even be used to measure how deep water is, because sound wave travels through the water also. The range of measuring the distance is about the distance between the obstacle to the sensor is 2 centimeters to 400 centimeters. So it works by sending out a sound wave at ultrasonic frequency and wait for it to bounce back from the object. So then the time delay between the transmission of the sound and the receiving of the sound is used to calculate the distance. So now here the signal has to be travel from the sensor to the obstacle. Again it has to travel back from the obstacle to sensor. So in total it is going to travel a distance twice, because from sensors to object, if I take a distance as s, again it has to bounce back and returning to the receiver. Again, it has to travel a distance of s. So the total distance it is going to travel is 2s. So if I want to calculate the distance off of the element, we are going to be considering. So the time delay between the transmission of sound and receiving of the sound is used to calculate the distance. It is done by using the formula distance is equivalent to speed of the sound multiply with delay for receiving the echoes divided by 2. So here the distance formula dividing by 2 because the sound wave is traveling a round trip, that is from the sensor and again back to the sensor, which doubles the actual distance. The ultrasonic sensor, which is HC SR04, is a typical ultrasonic sensor which is used in many projects such as obstacle detector and electronic distance measurement tapes. The figure shows the pin outlet of the ultrasonic sensor. The HCSR04 is an ultrasonic ranging module, which is an economical sensor which is used to provide a obstacle distance of 2 centimeters to 400 centimeters of non-contact measurement functionality with a ranging accuracy that can read up to 3 mm. So the pins which we are going to have for the ultrasonic sensor are VCC, which is a 5 volt supply, ground signal, then a trigger signal and echo signal. So here the trigger signal it is used for generating the sound waves. Echo pin which is used for collecting the signal, which is a receiver activity. So the sensor has 4 pins and these 4 pins we are going to be connected to the Arduino board. Out of these, 2 are power supplies, which is VCC and ground, whereas the trigger and echo pins, these 2 are of digital pins. So we can connect this trigger and echo pins to the DIOs of the Arduino board. Using the trigger pin, we can send the ultrasonic waveforms from the transmitter, and with the echo pin, we can listen the reflected signal from the obstacle by the receiver. Now we will see the specifications of HCSR04 ultrasonic sensor. The operating voltage is a 5 volts DC. The operating current is 15 milliamperes. Frequency of operation is 40 kHz. Minimum range is 2 centimeter or 1 inch. Maximum range you can have is 400 centimeters or 13 feet. So accuracy is 3 mm, which is a deviation you can consider. A measuring angle which should be less than 15 degrees. Dimension of ultrasonic sensor is 45 cross 20 cross 15 mm. So the working principle of ultrasonic sensor, which is HCSR04, this will emit from the transmitter the ultrasound at a frequency of 40 kHz, which travels through air, and if there is an obstacle, whenever or any object is present in this path, then it will be reflected back, receiving by the receiver. So considering the travel time and speed of the sound, then the distance can be calculated. In order to generate the ultrasonic, set the trigger pin at a high state for at least 10 microseconds. Then we will send out 8 cycles ultrasonic burst, which will travel at the speed of sound. The echo pins goes high after right away that 8 cycles of ultrasonic burst is set, and it starts listening or waiting for the wave to be reflected from the object. So if there is no object or a reflected pulse, the echo pin will be time out after 38 milliseconds and go back to the low state. So if the reflected pulse is received, the echo pin will be goes soon than those 38 milliseconds. So according to the formula for echo pin, amount of time where the echo pin is received high signal, we can determine the distance of the sound would be traveled. Thus, the distance from the sensor of the object is given as speed into time. So, the time is the amount of time the echo pin was high, and the speed is the speed of the sound wave, which is 340 meters per second. So, there is one additional step we need to do, that will divide the end results by 2 because the signal is traveling a trip, and that's because we are as measuring the duration the sound wave needs to be traveled to the object again bounce back. So the ground pins VCC we can connect to the power supply pins of the Arduino board, whereas the trigger pin and echo pin we can connect to any one of the DIOs, that is DIO 02, DIO 13. Out of these 14 pins we can connect any one of the pins. Now, how we will write the code for interfacing the ultrasonic with Arduino board is. So first we will define the pins corresponding to the trigger pin and echo pin. Let us assume if we are connecting the trigger pin to 9 and echo pin to 10, so then we are going to declare the int trigger pin is equivalent to 9, int echo pin is equivalent to 10. Then declare a variable, either it can be a long data type or it can be a float kind of thing. So for the travel time to get from the sensor and an integer variable distance. So in Arduino Scratch, we are going to have two loops. One is a setup, another one is loop. So this setup is for configuring the pins as well as for serial port. So in the setup, define the trigger pin as an output and the echo pin as input, and also start the serial communication for showing the results on the serial monitor. So void setup, pin mode. So we are going to connect the trigger pin as output mode, whereas the echo pin is configured in input mode. For displaying the data serially, we are going to generate the baud rate, which is of a standard baud rate we are taking 9600. So for that, you write serial dot begin 9600. In the loop, first clear the trigger pin to set that pin as low state for just few amount of time. Let us assume 2 microseconds or 10 microseconds like that. Then generate the ultrasonic sound by sending the trigger pin as high. This trigger pin will be high for 10 microseconds. So digital write, first we are making the trigger pin as low. We will wait for 2 microseconds. If you write just a delay of 2, it will use milliseconds. For exclusively mentioning as microseconds, we have inbuilt function that is delay microseconds. Next, to make trigger pin as 1, so we'll write a digital write trigger pin comma high. Then we need to wait for 10 microseconds. So delay for microseconds of 10. Then we'll make the trigger pin as low. So once the ultrasonic sensor generates the sound wave and the receiver will wait for the received echo signal through the echo pin. So using the pulse in, which is used for reading the travel time and put the value into the variable we are declaring as a duration. So this function has two parameters, pulse in. The first one is name of the echo pin, and for the second is the state of the pulse, what we are expecting for the echo pin, either active high state or active low state. So in this ultrasonic, we are waiting for high. So the echo pin will be high after sending 8 clock pulses or 8 cycles of the ultrasonic burst from the transmitter. So for reading the echo pin, for recording the sound wave, travel time in microseconds. So the duration is given as pulse in echo pin comma time. This actually start the timing once we receive the reflected sound wave. The echo pin will go to the low, which stops the timing. So at the end of this function, will return the length of the pulse in microseconds. So forgetting the distance, we will multiply the duration as 0.034 because the sound wave will travel at 340 milliseconds, where we want to consider this distance as well as the pulses which we are receiving is in microseconds. So this we will divide as 340 into 100 centimeters. 1 meter is equal to 100 centimeters. Seconds we are going to be converted into microseconds, that we can write as 10 to the power of 6 microseconds. Next here 10 to the power of 2, this will give us 10 to the power of 4. 1 0, here will get 3. So that is 34 divided by 10 to the power of 3, which will give 34 divided by 1000, which is nothing but 0.034. As the sound wave is traveling for 2 times, so divide by 2. So either we can multiply this duration 0.034 divided by 2, or we can do with like this. Duration is multiplied with 0.017. Both are valid. So what are the distance which we are going to be measured will be in centimeters. Then we want to print that data into the serial monitor. So for that we'll write serial.print at distance for labeling. Serial.print ln. After printing this one, then we need to advance to the next line. For that we'll use ln. So the distance variable and the units, which is centimeters. So at the end we will print the value of the distance in the serial monitor. So as the speed of the sound is 350 milliseconds, to calculate the distance we need to convert the speed of the sound into centimeter per microseconds, that is 0.034 centimeter per microseconds. So the slides are prepared by referring these references. Now we will see how we can interface the ultrasonic sensor with Arduino using the online simulator, that is OQUI. Now this is the online simulator we can carry out for checking the ultrasonic interface with Arduino board. So in this I am selecting the Arduino Uno. Again scroll down. Here you can see the environment IDE for Arduino Uno. So on right hand side we can see the interfacing circuit where already the ultrasound Uno board is placed. On right side we are going to have 2 loops. One is for setup, another one is for loop. Now here we want to interface the ultrasonic sensor. So component will fetch from the add a new part. Click on this. We will search for ultrasonic sensor. Here you can see HC SR04, which is a ultrasonic distance sensor. Right. Here we have the pin configuration. One is VCC, ground, trigger pin and echo. Now first we will connect the VCC. This we are going to be connect to a 5 volt supply. The next pin is a ground pin. This ground we will connect to the ground pin. Next, it is a trigger pin. So this trigger pin I am connecting to pin 8. So first we will declare this. So before void, we will declare this pin, that is int, some name we are going to give, that as trick is equivalent to which pin we are connected is 8. Next we have the echo pin. The echo pin we will connect to pin number 7. So that also we will declare here, int echo is equivalent to 7. So now we have declared two pins, that is trigger pin is connected to 8 and echo pin is connected to 7. Next, in the setup, we have to configure what is the pin mode for trigger pin as well as for echo pin. So for that, we use the statements which are pin mode. For this pin mode, first we are going to be place the trigger, and this trigger pin is a output pin. So we'll write as output. Next, we will declare one more pin, which is a pin mode for echo, and this echo pin is input type. So we have declared the pin assignment in the declaration as well as the pin mode for echo and trigger. So as we want to see the output in a serial mode, so we will write serial dot begin. So this serial dot begin, it is used for generating at what baud rate we want to transmit the data. So here we will select the baud rate as 9600. Next, for displaying the output, here we can declare either long type or float type. So here I am taking float, the variable which is a duration microseconds, and one more variable for evaluating the distance. So these are the two variables which we are going to be displaying. So in setup, we have configured the trigger pin as well as echo pin, and the baud rate is set. Next, we will move to while loop. In the loop, the first step is we have to make the trigger pin at active low signal. Then we need to make it as active high, that we need to wait for 10 microseconds. So first, straight away I am writing digital write. In the digital write, we will write the trigger signal initialized to low. Then we will provide a very small amount of delay. So this delay is in microseconds. The value which we are going to be provided is 2 microseconds of delay. Then immediately we'll make the trigger pin as high. Even these two steps you can neglect. Digital write. This we are going to be write for the trigger pin. The value which we are going to be write for the trigger pin is high. So this trigger pin will be kept in high state for 10 microseconds, so that we will provide with the delay in microseconds. So for how much amount of time we want to keep this one is 10 microseconds. So the trigger pin is given high, then we are waiting for 10 microseconds. Once the 10 microseconds is done, we are going to write again a digital write. The trigger pin will make low. So for the trigger pin, first we are keeping low, then high, then again low. So this high period is 10 microseconds. So here we have configured the trigger pin. Once this is initiation is done, the ultrasonic sensor, it will generate the sound waves. Next we are going to read the data which you are going to get on the receiver, which is through echo pin. We will read the echo pin which will provide the duration in microseconds. So for reading, we have pulse in command. So this pulse in command, through which pin we want to read echo, and we have to pass one more argument. Pulse in will take two arguments. One is through which pin we are reading the data, and what is the value we are expecting. Either this value can be low or high. So in this case, we are expecting high for the pulse in. So whenever we have received the pulse in as high, it indicates we have received the echo signal. If high pulse is not generated, it will wait for 38 milliseconds and it will come out of it. So once the duration we are received from the echo, we are going to calculate the distance. So what is the distance formula? So for distance, we are given the variable is distance, and this we are going to be measured in centimeters. So here the multiplication factor, first we will write the duration in microseconds. This we are going to be multiply. There are two ways for writing this. One you can write as 0.034 divided by 2. Otherwise, this 0.034 divided by 2, straight away we can write this one as 0.017. So now this we are going to get for the variable distance. So whatever the distance which you have measured, that we want to display through the serial port. So for that, we will write serial dot S is capital. We want to print. So serial dot print. So what we are printing is, first I want to get a distance variable. First we will check without this, what is the output we will get. Just I am printing the distance. Okay. After every accepting the distance, so we go for providing a delay for 500 milliseconds. Right. Now we will run this code. So on right hand side you can see the run button. Okay. Serial dot begin 9600. Now here you can see the distance is displaying, but there is no separation. So for that, what we'll write is, after every data is printed, we'll go for new line. So print ln we will take, one after the other can get. Now for varying the distance, just you double click on the ultrasonic sensor, vary the distance. See what is the distance we are having? 226. Here we will get approximate 224.67 we are getting. Still, if you are changing the distance, accordingly we will get the displacement here. Okay. Here in the display, if you observe, it is giving a quantity 138.19. What it is? the units I want to mention. So for that, here I'll mention a string centimeters. Now when we run this, so you'll get the distance. After that, you get centimeters. Serial dot print. This I'll take as print. Here we'll write print element. Now here you can see the distance we are going to give as 138.18 units also. Now this I want to mention what is that quantity. So for giving more information at the output, so here we will write one more print statement. This print statement is distance. Now I'll run this. Serial dot print. Now you can get at the output side like distance colon, how much displacement is there between the sensor. So as it is a simulator, we are not having a physical obstacle or object. By varying this slide, we can vary the distance from the sensor to object. Okay. So this is about writing the scratch module for ultrasonic sensor, where we are declaring trigger pin and echo pin. So what are the pins which we are using? The same pins we can assign here. It is not mandatory to use only 8 and 7. You can go for from 0 to 13. Any pins you can connect. Then two variables. One is for measuring the duration, then distance. So for that, either you can take this one as a float type or long type. Next, in the setup, we are going to write three constraints. One is for configuring the trigger pin, configuring the echo pin, and setting the baud rate for serial communication, which is 9600 we are using. In the loop, first we will pass the trigger one as low, then high, then low. So this high, it has to maintain for 10 microseconds. After the pulse is 0, once we made the trigger pulse is equivalent to 0, then we are ready for expecting the data from the echo pin. So for that we use pulse in echo. For what value we are checking in the echo is high. So once it is received, it is going to give actually the duration. To convert into a distance, you'll write a distance is equivalent to duration in microseconds, multiply with 0.034 divided by 2, or simply you can write 0.017. Then we can go for printing. So this is a small module where we are implementing the interfacing of the ultrasonic with the Arduino Uno. Thank you. So in this session, we have mainly discussed how to interface an ultrasonic sensor with the Arduino.
Like, share and subscribe. Hit the bell icon for more updates.